Hey guys, welcome back to the channel. My name is Zahir, and today we'll be writing an MCP client as well as an MCP server from scratch. That's what we intend to do. But let's spend 30 seconds on what MCP is. Let's try and understand what MCP is. A brilliant illustration is something that you're seeing on the screen that perfectly captures what MCP is. This illustration is by Nora Sakal. I have linked the website here as well. MCP is essentially an open protocol that standardizes how applications provide context to LLMs. This was essentially invented or created by Anthropic, I think, late last year, and they're calling this the USB-C port for AI applications. Now, think about your laptop. There is just one single port which can essentially be used to connect to a display, to to essentially connect to a phone, your headsets, maybe. I mean, think about USB-C, right? And think about a protocol or a standard way to connect to multiple peripherals. You want the same to your LLMs. Today, there are tons of APIs, that your LLMs can work with, but imagine the kind of integrations, the custom code that you have to write there. All of that can be abstracted. All of that can be simplified or standardized by MCP servers or MCP as a whole, right? So we'll talk about it when I write those simple implementations. You'll see that in part one or version one of this particular exercise. Today we'll be creating a MCP client as well as MCP server from scratch. Very simple implementation so that we get the fundamentals right, and we'll be building or adding complexity or complex features to that. All right. All right. With that, let's get started. All right, so the first thing that we'll be doing is we'll need two libraries to essentially make this work. One is the MCP SDK by Anthropic. It's a Python SDK. We'll need that. And the other one is the OpenAI client. Again, it's a package by OpenAI. So we'll install them both. I have the command for MCP, pip install MCP CLI. So let me do that. I have that installed already. I will do the same for OpenAI. I have that installed already as well. So, all right, let's get started with creating the server first. The reason I'm creating the server is because I want to implement the operation or a tool first, and then call that by creating a client. All right. So let's create a file. Before that, I want to tell you what we are creating a server on. We want to create a server for calculating, or we want to create a server to calculate body mass index. It's a very simple implementation. You don't need to make an API call or do complex calculation. This is a simple math method, right? So let's implement that. So I'm going to create a file and name it, sorry, BMI server.py, right? Now we need to essentially create a server, right? And to create a server, we will be using the MCP package. Let me quickly type that. All right. So what we're doing essentially is we are using the FastMCP class from the FastMCP module, which is located in the mcp.server package. Now this class essentially is designed to facilitate the creation of an MCP server. How do we do that? We essentially create the instance of that particular class and pass the name that we intend to give to our server. So in this case, it is BMI Server, and this should do. The next thing that we'll do is we will create a tool. Now, how do you do that? You essentially use a decorator. Let me quickly type that at mcp dot tool. That's a decorator, and any method that this particular decorator will be on top of will essentially become a tool, meaning that in MCP frameworks, decorator at MCP tool are used to expose functions as callable tools over the MCP protocol. So in this case, the function that I want to expose as a callable tool is calculate BMI. And this takes two things, or two parameters, one or two arguments rather. It takes weight in kg. So I'm going to add underscore weight underscore kg, and the data type would be a float. Similarly, height, which is going to be in meters, and the data type in float. Okay, underscore kg and underscore m is just to denote that that's what we intend to use this for, and it will essentially return a float. Now, I also want this to, this method to essentially have a clear description of what this does, because this will become the context, just like we have seen this in agents. This description will become the context to the LLM. How do we do that? I'm going to just accept the code and fix this. So it's saying calculate given BMI, given weight in kg and height in meters. And it is basically handling an edge case, and it is returning the BMI, which is basically weight over height squared. Simple math, right? Now with that established, what we will do next is we will essentially write a conditional block that checks if this is basically this particular script is being run directly, or it is being essentially imported as a module. We don't want this to be imported as a module, right? We want this to run independently. So what we will do is we'll write this. However, we also need to give the kind of transport we essentially want here, and the transport parameter takes in the standard input output, basically allowing it to handle incoming requests and execute the exposed tools and functions. All right, this should do it. Now I'm going to save this now and run the script just to check how this is working. All right, no issues here. I'm going to kill the terminal, and just so that we understand this, what I'll do is I'll just print the name of the server. Just going to say starting server MCP name. This should do. Let's see if everything's working as expected. I'm going to run this file independently now, and as you can see, starting server BMI server, that's the name that we gave. All right, let me just quickly kill this server now, and now let's write the client. Right, we've created this simple server. Now let's create the client to essentially communicate with this particular server and leverage the tool. Let's call the client BMI client.py. First, we'll essentially start importing the necessary modules. Some of the modules that we need are OpenAI, essentially to essentially create the OpenAI client and talk to the OpenAI API, the LLM in this case. The next module that we'll need is obviously the MCP client session and the stdio server parameters. You can go through the documentation to understand what this is, but let me quickly import that. So parameters, I think these are the two. That's good enough. We'll also use we'll import from mcp.client.stdio import stdio client. We'll also import the stdio client. So we've created the server parameters. We've already set the OpenAI API key. Now what we should be doing is essentially creating an LLM client first, so that we can talk to that particular OpenAI API or OpenAI LLM API, right? So let's create a method. We obviously created this client several times, so you should be good. Now what we will be doing is we will essentially create a method which returns a prompt, but the prompt will be well structured, meaning that the prompt will have the user query and also some instructions on how we want the prompt to essentially return a response. Now this prompt is specifically for talking to the server and the tools that the server is offering, correct? So let's actually build the prompt. So I'm going to create a method get prompt to, this is a generic prompt base. It could be any server with any tool that is exposed, but our goal is to essentially write a simple prompt so that we send that prompt to the LLM, and the LLM is able to essentially identify the tool and the necessary arguments it need to pass to that particular tool. So the method will take query, which is the original query from the user, and it will also take the tools that are available and will pass it. I'm going to show you how we are going to pass it in a bit. Uh, so what we'll do is we'll come back to this in a bit. So this will return the prompt. Okay. We'll come back to this particular method in a bit because I want you guys to understand how tools work. So let's leave it at that. Now what I intend to do is we'll create the run method, which is, you can name it anything. This method will essentially instantiate the SCD client and create a session, identify the server, extract or get all the tools from the servers that it has access to, and essentially, uh, you know, it can pass those tools to the method or the prompt that we intend to create, and we use the fully composed prompt, send it to an LLM, identify the tool, and execute the tool. All right. So let's create the run method. You can name it anything. So I'm just going to name it run. Remember, the prompt still still needs to be written. We'll get back to the prompt in a bit. Okay. So we'll write this as a method now. Now this method will basically take the query from the user, and this will be a string. What we do is we'll start the BMI process servers using the SCDO client. We will get access to its read and write streams. And we do that by async with SCDO client server parameters, and we get access to its read and write streams. And then we create a session and initialize it. How do we do that? We simply instantiate session by passing the read and write streams. Just gonna use that in a bit, but I want this. I want this to be written line by line so that we are following along, right? And then I want to initialize the session. Okay. We create a session initialization. This sets up the, so what the initialize, the session initialize method does is it sets up the communication between our client and the server. We then ask the server for all the tools, get the list of available tools, and await sessions dot get underscore tools. All right, so this is not the method. The real method is list underscore tools. Now we ask the server for the list of tools. In our case, it will return the calculate BMI function that we exposed earlier. If we had several servers here, like all of those servers tools would be listed here essentially. What we'll do is just so that we know, we are sure that we have gotten this right, we will essentially print the list of tools. Okay. Now let's stop it here, and we will quickly write a condition to run this. We'll calculate BMI for a person with 70 kg knee height, and we'll pass this particular query. This is a missing method, so I need to use a kind of run. All right, and I could have awaited that as well. So, sorry. All right, so we have this. Let's see if if it is able to talk to the server, and essentially, basically, it is. Let's see if it is able to use the server parameters and talk to the server, and the server that we just created, and essentially list the tool here. In this case, I should be able to see the tool calculate underscore BMI. All right, so all right, so I just ran the method. Oh, sorry, I just ran this particular file, python bmi client.py, and as you can see, we were able to print that particular tool, and the tool is calculate BMI. All right, great. So the number of tools that are available, it's saying next cursor meta, we can ignore for that now. But in terms of tools, these are This is what is available. All right. So what we'll do now is, now that we are able to capture the tool from the server that we just created using the server parameters and the stdio server parameters that we just created the instance of the class of. Now what we will do is we will simply create or basically pass the tools to this particular prompt and create the prompt. Now let me quickly walk you guys through what the prompt looks like. But before that, what we've done is basically we are passing the query, that is the user query, as well as the tools, the list of tools that we captured using the session. That is by by looking at all the servers that we have access to. In this case, we have access to one server, which is BMI server, and we have captured the tool from that, and we need to basically pass that tool as context to the LLM. How do we do that? We write a prompt. You're a helpful assistant with access to these tools, and the description. How did we get this description? We essentially, this method takes the description as the argument as tools, which we'll pass, and I'm going to do that in a bit. Now what we intend to capture from the tool is the tool name, the description as and the input schema, so that the LLM understands what is the appropriate tool for the incoming query, and it knows the name of the tool, so that it identifies the name of the tool and returns that in this particular schema that I want, that is tool, the tool name, and the arguments. The argument also is basically as part of the context that we are providing of the tool. And how do we do that? We basically pass the schema field which we just captured from the session. All right. Now let me call this particular method, the get prompt to identify tool and arguments method, and pass the tools object as well as the query to it. And I'm going to print the prompt and see if everything's working as we expect it to. Just going to simply print the prompt, do nothing else there, and run this particular method again. Sorry, we'll run the script again, Python BMI client, and we were able to print the prompt. But I'll also show you how we are passing the context. You are a helpful assistant with access to these tools, and we are passing calculate BMI given weight in a kg, and height in meters, which is basically the description, and the properties or the schema looks something like this, so that the LLM understands how it needs to compose the arguments for the method that it has just identified. All right. So we are done with one task, which is basically to identify the method or the tool that we need to work with. Now we need to execute the tool, and this has been brilliantly abstracted by the MCP package. All you need to do is essentially, let me quickly make some space here. All right, so before that, we obviously now we need to essentially pass this particular prompt and see, we'll pass this particular query, I'm sorry, to the LLM and see how the LLM identifies the relevant tool name and the argument. So to do that, we will simply, let's call the variable LLM response and call the LLM client, the method that we just created, and pass the prompt to it. All right, and we'll print the result. So let's run this particular class now. I'm going to clear everything and run that particular script again, BMI-client. So as you can see, it was able to identify the tools. Now we're making an LLM call now. This should take a few seconds and we should get the response from the LLM. All right, so it's saying GPT-4o mini. Oh, I'm sorry, guys. It's not 4.0, it's 4.0. Let me quickly make that change. Save that, clear everything here, and run the script again. So it's check this not subscriptable. So I can just call that as an API. Yeah, this should do. Let me run this again. Cool. So we've seen that it has successfully identified the tool, which is basically calculate BMI. And it has also captured the response, the arguments, which is basically the weight and the height. Weight is in kgs and the height is in meters, which is perfect. All right. Let me show you the query again. The query is calculate BMI for a person with weight 70 kg and height 0.75 meters. All right, so we have done the first bit, which is basically to identify the tool using an LLM and also identify the arguments that we need to pass to the tool. We have it covered till there. Now let's look at how to execute the tool without having to explicitly write the code to do that. To do that, essentially, the MCP server, the MCP SDK has a method called session.callTool. Let's implement that. We need to now first capture or convert the response into a dictionary. So what I will do is tool call is equal to json.loads and convert that particular LLM response into a dictionary. And I'm hoping I'm not going to write any, method to check if it's a dictionary or not. I'm assuming that everything should work as expected because this is a very simple implementation. So we're assuming that we have got the tool, we have got a valid JSON as a response, and we have the relevant, fields that we intend to capture. So what I need to do to execute the tool is I'm going to simply say await session, release the same session to call the tool, and we'll pass two arguments. We'll pass the tool, I'm sorry, and we'll also pass the arguments. These are the only two methods that we need to pass. You could do that in a different way. I could do this also. And then we'll simply, for now, print the result and check if this is working as expected. Kill the server now. Kill the terminal. And let's run the script again. We're running the client. The client will first print the available tools, and then it is showing the, oh great, in fact it has printed the text content. As you can see, it was able to generate the response in a perfect valid JSON, and we were able to execute the tool, and it has returned the BMI, which is basically this. So let me simply say content, and I'm going to take the first element in the content and simply print the result, and we'll see now. We'll simply say, all right guys, that's how you build an intelligent MCP client that can call tools dynamically using OpenAI and a BMI server that magicalizes in combining tool discovery, LLM prompting, and tool invocation, all within a simple and elegant flow. I hope you like this particular video. I hope implementing this was easier. We will look at multiple versions of doing this in the future. Thank you.